So hello everyone, today we are going to study chapter 2 of class 9th Ncert, that is polynomials. So let's start. Introduction. You have studied algebraic expressions, their addition, subtraction, multiplication and division in earlier classes. You also have studied how to factorize some algebraic expressions. You may recall that the algebraic identities x plus y square equal x square plus 2xy plus y square, x minus y whole square equal x square minus 2xy plus y square, x square minus y equal y square equal x plus y and x minus y, and their use in factorization. In this chapter we shall start our study with a particular type of algebraic expressions called polynomial and the terminology related to it. We shall also study the remainder theorem and factor theorem and their use in the factorization of polynomials. In addition to the above, we shall study some more algebraic identities and their use in factorization and in evaluating some given expression. Polynomials in one variable. Let us begin by recalling that a variable is denoted by a symbol that can take any real value. We use the letters x, y, z, etc. to denote variables. Notice that 2x, 3x, minus half x are algebraic expressions. All these expressions are of the form of a constant into x. Now suppose we want to write an expression which is a constant into a variable and we do not know that what the constant in such cases we write the constant as a, b, c, etc. So the expression will be axa. However, there is a difference between a letter denoting a constant and a letter denoting a variable. The values of constant remain the same throughout a particular situation, that is the values of constant do not change in a given problem, but the value of a variable can keep changing. Now consider a square of side 3 units. What is its perimeter? You know that the perimeter of a square is the sum of the lengths of its 4 sides. Here each side is 3 units, so its perimeter is 4 into 3. It means 12 units. What will be the perimeter if each side of the square is 10 units? The perimeter is 4 into 10, that is 40 units. In case the length of each side is x units, the perimeter is given by 4x units. So as the length of the side varies, the perimeter varies. Can you find the area of the square PQRS? It is x into x, that is x square units. X square is an algebraic expression. You are also familiar with other algebraic expressions like 2x x square plus 2x x cube minus x square plus 4x plus 7. Note that all the algebraic expressions we have considered so far have only whole numbers as the exponents of the variable. Expressions of the form of this form are called polynomials in one variable. In the examples above, the variable is x. For instance, x cube minus x square plus 4x plus 7 is a polynomial in x. Similarly, 3y square plus 5y is a polynomial in the variable y, and t square plus 4 is a polynomial in the variable t. In the polynomial x square plus 2x, the expressions x square and 2x are called the terms of the polynomial. Similarly, the polynomial 3y square plus 5y plus 7 has 3 terms, namely 3y square, 5y and 7. Can you write the terms of the polynomial? Minus x cube plus 4x square plus 7x minus 2. This polynomial has 4 terms, namely minus x cube, 4x square, 7x and minus 2. Each term of a polynomial has a coefficient. So in minus x cube and 4 plus 4x square plus 7x minus 2, the coefficient of x cube is minus 1, the coefficient of x square is 4, the coefficient of x is 7 and minus 2 is the coefficient of x to the power 0. Remember, x to the power 0 is always equals to 1. Do you know that the coefficient of x in x square minus x plus 7? It is minus 1. 2 is also a polynomial. In fact, 2, minus 5, 7, etc. are examples of constant polynomials. The constant polynomials 0 is called the zero polynomial. This plays a very important role in the collection of all polynomials, as you will see in the higher classes. Now consider algebraic expressions such as x plus 1 by x, under root x plus 3 and cube root y plus y square. Do you know that you can write x plus half 1 by x equal x plus x to the power minus 1. Here the exponent of the second term, it means minus 1, which is not a whole number. So this algebraic expression is not a polynomial. Again, Under root x plus 3 can be written as x to the power half plus 3. Here the exponent of x is 1 half, which is not a whole number. So is under root x plus 3 a polynomial? No, it is not. What about under cube root y plus y square? It is also not polynomial. It is also not a polynomial. If the variable in polynomial is x, if the variable in a polynomial is x, we may denote the polynomial by p x or q x or r x, etc. We can take any a b c d, any name, any alphabet. So for example, we may write px equals 2x square plus 5x minus 3 qx equal x cube minus y minus 1, ry equal y cube plus y plus 1, su equal 2 minus y minus u square plus 6u to the power 5. A polynomial can have any number of terms. For instance, this is a polynomial with 151 terms. Consider the polynomial 2x 2 5x cube minus 5x square y and y to the power 4. Do you see that each of these polynomial has only one term? Polynomial having only one term are called monomials. Mono means one. Now observe each of the following polynomials. These polynomials, how many terms are there in each of these? Each of these polynomials has only two terms. Polynomials having only two terms are called binomials, and bi means two. Similarly, polynomials having only three terms are called trinomials. In these, tri means three. Some examples of trinomials are these, this and this. Now look at the polynomial px equal 3x to the power 7 minus 4x to the power 6 plus x plus 9. What is the term with the highest power of x? It is 3x to the power 7. The exponent of x in this term is 7. Similarly, in the polynomial qy equal 5y to the power 6 minus 4y square minus 6, the term with the highest power of y is 5y to the power 6 and the exponent of y in this term is 6. We call the highest power of the variable in a polynomial as the degree of the polynomial. So the degree of the polynomial is 3x to the power 7 minus 4x to the power 6 plus x plus 9 is 7, and the degree of the polynomial 5 y to the power 6 minus 4y to the power y square minus 6 is 6. The degree of a non-zero constant polynomial is 0. Example, find the degree of each of the following given below. So let's find. Here the highest power is 5. So the degree in this case will be of 5. Here the highest degree is 8. So the degree will be 8. Here it is only written 2, and it can also be written as 2x 0, x to the power 0, and x to the power 0 is equals to 1. 2 into 1 will be 2. So the highest degree is 0 in this case. Now observe the polynomial px equal 4x plus 5, qy equal 2y, rt equal t plus under root 2 and su equal 3 minus u. Do you see anything common among all of them? The degree of each of these polynomials is 1. A polynomial of degree 1 is called linear polynomial. Some more linear polynomial is in one variable are 2x minus 1 under root 2y plus 1, 2 minus u. Now try and find a linear polynomial in x with three terms. You will not be able to find it because a linear polynomial in x can have at most two terms. So any linear polynomial in x will be in the form of ax plus b, where a and b are consonant and is not equals to 0. Similarly, ay plus b is a linear polynomial in y. Now consider the polynomials 2x square plus 5x square plus 3x plus pi x square and x square plus 2y 5x. Do you agree that they are all of the degree 2? A polynomial of degree 2 is called a quadratic polynomial. Some examples of quadratic polynomial are 5 minus y square, 4y plus 5y square and 6 minus y minus y square. Can you write a quadratic polynomial in one variable with 4 different terms? You will find that a quadratic polynomial in one variable will have at most 3 terms. if you list a few more quadratic polynomial, you will find that any quadratic polynomial in x is of a form of ax square plus bx plus c, where a is not equals to 0 and a, b, c are consonants. Similarly, quadratic polynomial in y will be of the form ay square plus by plus c, provided a not equals to 0 and a, b, c are constants. B can be 0, C can be 0, but A cannot. We call a polynomial of degree 3 a cubic polynomial. So, some examples of a cubic polynomial are these, this and this. How many terms do you think a cubic polynomial in one variable can have? It can have at most 4 terms. At most 4 terms. Not exceeding 4 terms. These may be written in the form ax cube plus bx square plus cx plus d, where a is not equals to 0 and a, b, c and d are constants. Now that you have seen what a polynomial of degree 1, degree 2, degree 3 looks like, can you write down a polynomial in one variable of degree n for any natural number n? A polynomial in one variable of x of degree n is an expression of the form an xn plus an minus 1 x minus 1 plus to this, where these are constant and an is not equals to 0. In a particular, if a 0 equal a1, a2, a3 and from for to an equals 0, all the constants are 0, we get a 0 polynomial which is denoted by 0. What is the degree of the 0 polynomial? The degree of 0 polynomial is not defined. So far we have dealt with polynomials in one variable only. We can also have polynomials in more than one variable. For example, x square plus y square plus xyz, where variables are x, y, z, is a polynomial in 3 variables. Similarly, p square plus q to the power 10 r, where the variables are p, q, r, u, q plus v square, where the variables are u and y, u and v are polynomials in 3 and 2 variables respectively. You will be studying such polynomials in detail later. So here is the exercise. Let's try it on